Welcome to another video. In this video, we are going to solve the system of linear equations by using Cramer's rule. In the previous video, I have provided the proof for this rule. So in this video, we are going to make use of it, okay? In this video, our job is to find the value of x, y, and z such that when we plug in the values here in every equation, it satisfies. Which means that for equation 1, if we plug in a value x, y, and z and calculate it, it should give 5. Then for 8 for 2 and 5 for the equation 3, okay? Therefore, without further delay, let's begin solving. The first thing that we need in Cramer's rule is our determinant d. And the determinant d is formed by the coefficient of the system of linear equations. Therefore, let us calculate our determinant d. Here we have d equals to, let's write the coefficient of x here, y here, and z here, okay? So, here our coefficient of x are 1, 2, and 6. Then y are 3, 1, and 1. And z are -2, 4, and -3. So this is our determinant d. Now our job is to calculate or evaluate this determinant. To make it easier, what I will do is I will operate one of the rows such that any of the entry becomes 0, okay? Therefore, while we expand it, it will be easier because when we use the cofactor, when we use the factor, if it is 0, then we don't need to worry about, okay? Now what I will do is I will make this row 2, this 2 entry 0, okay, by subtracting from the row number 1. Therefore, what I will do is I will operate this row 2 by taking -2 times of the value of row 1 and adding to row 2, okay? So by doing this, our values will now become 1, 3, -2, and here it will become 0, and we will have -2 times 3 is -6 plus 1 is -5. Now we have -2 times of -2 is 4 plus 4 is +8, and 6, 1, -3. So this is our determinant after the operation. And from the properties of determinant, if I do this, our determinant value will not change, okay? So to understand that, you have to visit the properties of determinant video. Now I will expand through C1, okay? This C1. Now our determinant will be 1 times, from here, 5 times 3 is +15, minus 1 times 8 is 8, plus 6, and this 0 we do not have to calculate, and here we have 6. Now our minors are here. 3 times 8 is 24, then minus of 5 times 2 is +10, so it is 10, and our determinant value will be 7 plus 24 minus 10 is 14 times 6 equals to 91, okay? So our determinant value is 91. Now our next job is to find the value of dx, okay? And what did I say? The dx is a determinant calculated by replacing the column containing the coefficient of x with this sum, right? So we have to replace this column 1 by this sum. So by doing this, we will get 5, 8, 5, then remaining, it will remain same, and this is our dx. Now to make it easier, what I will do is I will make this 5, this row 3, 0, okay? Therefore, what I will do is I will operate this row 3 by taking minus of row 1 and adding to row 3, okay? So by doing this, what I will get is my determinant will be 5, 3, -2, 8, 1, 4. 5 minus of 5 is 0. Then here negative 3 plus 1 is negative 2, and negative times negative is positive, times 2 minus 3 is negative 1. So this is the modified values of a determinant, and now we have to evaluate this, and we'll expand through C1 again. We will get 5 times, this one is positive 1, and minus of minus 8, right? So we'll get plus 8. Then our second is this one, negative 8, and we have to delete this, and these are the values that are left. So our negative 3 times 1 is negative 3. Then negative is positive, and we have negative in middle, so 2 times 2 is 4. So our determinant is now 5 times 9 is 45, plus 3 plus 4 is negative 7, times 8 is 56, right? 56. So the value is 91 again. Now next one is to calculate dy. Okay, now dy is calculated by replacing the column containing the coefficient of y by this sum, right? So our determinant will be now 1, 2, 6, 5, 8, 5, negative 2, 4, negative 3, and this is our dy determinant. And similar to above, I will also make this 0. So to make this 0, what I will do is I will operate row 3 by taking negative 6 of row 1 and adding to row 3. Okay, now our values are 1, 5, negative 2, 2, 8, 4. Here negative 6 times 1 is negative 6, plus 6 is 0. Negative 6 times 5 is negative 30, plus 5 is negative 25. Negative 6 times negative 2 is 12, minus of 3 is positive 9. So these are our new values. Okay, and we will expand through column 1 again, expanding through C1. We will now get 1 times 8, 9 is 72, minus of 100, 25 times 4 is 100, so it will be plus 100, minus of 2, then this will be remaining, so 5, 9 is 45, minus 25 times 2 is 50, so it is 50, positive, so minus will remain like this, and our answer will be 172. This one will be minus 5 times 2 is negative 10, so minus times minus is positive, so it will be 10, so our answer will be 182. Okay, now our next job is to find dz. Okay, so our dz will be replacing the column or containing the coefficient of z by the sum. Okay, so it will be now we have to evaluate this determinant. Similar to the above one, I will also operate same thing, which is R3. I will take minus of 6 times of R1 and add to R3 such that the R3, this 6 becomes 0 to make our life easier. Okay, now we have 1, 3, 5, 2, 1, 8. So we have negative 6 times 1 is negative 6, plus 6 is 0. And we have negative 6 times 3 is negative 18, plus 1 is negative 17. And we have negative 6 times 5 is negative 30, plus 5 is negative 25. Like this, okay? And this is our modified determinant after the operation. Now we have to evaluate this by expanding through C1 again. Expanding through C1. We get 1 times negative 25 is negative 25, Then here is negative 17 times 8, right? So we have to use positive 136, then negative 2, then this will be left. So 3 times negative 25 is negative 75. Then here negative times negative is positive, and 17 times 5 is 75 is 35. 5 1 is 5, 6 7 8. So it is 85, right? And our value will be 136 minus 25 is 111, minus 85 minus 75 is 10, right? Times 2 is negative 20. So it will be 91 again, okay? Now we have got the value for dx, dy, and dz as well as d. So according to Cramer's rule, now it is simple that to calculate x, just we have to divide the determinant value of dx by our original determinant, which is our original determinant is 91 and dx is also 91. So it will be 91 upon 91, which will be 1, okay? And y value will be dy upon d, and dy is 182 upon 91. So it will be 2, and z value is dz divided by d equals to 91 upon original determinant is 91, so it is 1, okay? Therefore our values are x equals to z equals to 1 and y equals to 2, okay? Now our last thing is to verify whether when you plug in the value x equals to z equals to 1 and y equals to 2 in the equation, whether they are getting satisfied or not, okay? So our first equation is x plus 3y minus 2z equals to 5. So our first equation is x plus 3y minus 2z equals to 5, okay? So substitute the value 1 plus 3 times 1 is 1 plus 3 times 2 is 6 minus 2 times 1 is 2 equals to 5. This should be equals to 5, okay? So we have 1 plus 6 is 7 minus 2 is 5 equals to 5. So the equation number 1 is satisfied. Now let's check for equation number 2. Equation number 2 is 2x plus y plus 4z, okay? So we have 2x plus y plus 4z equals to 8. So substitute the value x equals to 1, so we will get 2 plus 4 times of 1 equals to 8. So this one is 4 plus 2 is 6 plus 2 is 8 equals to 8. So this equation number 2 also got satisfied, okay? Now let's check for equation number 3, okay? So equation number 3 is 6x plus y minus 3z. We have 6x plus y minus 3z equals to 5, okay? So substitute the value of x. 6 times 1 is 6 plus 2 minus 3 of 1 equals to 5. So this one, 6 plus 2 is 8, 8 minus 3 is 5 equals to 5. Therefore, by substituting the value of x, y and z in the above equation, all of the equation got satisfied, okay? Therefore, our values of x, y and z are x equals to 1, y equals to 2 and z equals to 1, okay? One last thing is that in this equation involving 3 variables and 3 equations, you should make sure that it satisfies all of the equation, okay? Because there are some situations where it satisfies 2 of the 3 equations and 1 equation it doesn't satisfy, therefore getting our value wrong. Therefore, to verify it, you have to substitute in all and make sure that it satisfies all of the equations, okay? I hope you all would have enjoyed this video and understood how to evaluate. In next video, I am going to solve one more problem having different form of equation, okay?